Welcome dear students, Dr. Hadi here. Today I brought another topic, very interesting of course, that is the test used to check the purity of fats and oils. Dear students, as we know that we use different types of oil and fats at home, and we don't know whether the oil or fat is original or not. We don't know whether the oil or fat is genuine or not, whether is there any problem in its purity or not, because nowadays almost every country with some variable degrees there is adulteration. Adulteration means to change the quality of a product, whether it is drug or whether it is some food item, because selling genuine original food item, that is so nice, so good, but in order to increase the income, some greedy people around us, they change the quality of the food item, including different types of oil that we use. They only change, they adulterate the quality, because with doing this kind of action they will earn some extra money. But we are still people, we are human, so we can't let them do this. We can check the fats and oil, either they are pure or not, either some changes have been done in it or not. So it is also important for the students to know. Maybe sometime they become an expert in a lab to check these sorts of tests. So let's start with the first one. The first test is the iodine number. Iodine number, we will discuss them all in detail, but one by one we will tell you. The first one is the iodine number. Iodine number is actually, this number is used to test the degree of unsaturation. We know very well that the fats all are of two types. One is the saturated, one is the unsaturated. The unsaturated fats are those which contain double bonds. So this test is done to check the number of double bonds in the unsaturated fatty acid. Let's suppose what we will do to carry out this test. You need 100 gram of fats, any oil that you think that this contain how many saturation is there, how many double bonds are there. You need to take 100 gram of the sample. Maybe this is oil or fat. So then you will add iodine, okay, and then you will check how much iodine gram, or we will say number, because then we convert them into number as well. So how many grams of iodine have been absorbed by the 100 gram of the fats. Then we will check how much iodine is absorbed. Let's suppose if after the experiment you came to know that 10 gram, let's suppose 10 gram of iodine is absorbed, so we say this is the iodine number is 10. Okay, if you came to know that 50 gram of iodine is being absorbed, then the iodine number will be 50. So very easily you will find this is also one more important. How we will find, we will come to know that 10 gram of iodine is absorbed, or 50 gram whatsoever number has been absorbed. So how we will find it? How we will know iodine number is a laboratory titration process. There is another process that we will perform in the laboratory, and that process is called as titration. With the help of titration, that we will not discuss this process, neither this is important for us Maybe this is a part of our topic today, but still I'm going to tell you that with the help of a titration process and using formula, we will come to know how many grams of iodine are absorbed. So you can't see with your eyes that look, I'm going 10 gram of iodine absorbed or 20 gram. You can't see them, right? But in order to check out the number of iodine, the gram of iodine absorbed, we do another lab process that is called as titration, and within the titration we use some formula as well. So don't worry about this. We will get the number, whether it is 50 or 100, whatsoever number is, we will get the number. And once we get the number, then what we do, we compare that number, we compare that value with the pre-established numbers. Pre-established numbers are here, look at that. That is also called as standard. And so standard values are already present. Already we have the coconut oil. Let's suppose there's a coconut oil, the original coconut oil has the iodine number of 7 to 10, right? 7 to 10. Similarly, butter has 25 to 28, palm oil has 45 to 55, and olive oil has 80 to 85. Now let's suppose here you got palm oil. Let's suppose this is palm oil. This is palm oil, and when you react it with the iodine, and at the end you came to know that 50 gram of iodine is absorbed. So now you compare this value with the standard value. Now for palm oil, the iodine number is ranging between 45 to 55. So this 50 value comes in between the two. This value come in the range of this. So that is the palm oil is original, that is genuine, that is pure, right? Because the number is quite similar, matching with its standard value. And let's suppose if the number come out to be 70, let's suppose, just suppose value, if the number come out to be 70, then it means that this palm oil is not pure, and some kind of adulteration has been done in that, because its iodine number is somewhat else other than between 45 to 55. So you can do this test for other fats and oil. The basic purpose of this test is this test can tell us the double bonds present in the fatty acid, because we know that in a fatty acid there are carbon, okay, fine. If there is one double bond, so there will be iodine number will be less, and if there are more double bonds, so that similarly iodine number will be more. Because when you take 100 gram of fat, then it does not mean that it contains only one fatty acid. There will be hundreds of fatty acids molecules, and maybe there's 100 and 120, 150 bonds will be there, double bonds will be there. So by this number, if you got increased iodine number, we will assume that there are many more double bonds, more unsaturation is there. And if the iodine number is less, then we will assume that the double bonds are less. So we finally got the first test, iodine number. So beautiful, so wonderful. And now we will come to the next test, that is called a saponification number. Saponification number is another test to check the purity, the quality of some fats or oil. But this test targets something else rather than double bonds, right? So in saponification, we will react potassium hydroxide with any fats or oil, right? Any fats or oil, you will react them, and what you have to do, you have to again to take 100 gram of fats and oil, and then you will react it with potassium hydroxide. What is saponification? Actually, saponification is something else. That let me write something here. Saponification means that when some lipids, let's suppose that we have glycerol, that is glycerol. I have already discussed on it saponification. That is glycerol, and glycerol is linked with a fatty acid. Then it is linked with another fatty acid, and it is linked with another fatty acid. Fine. Now if you react this lipid with some alkali, like sodium hydroxide in soap formation, or potassium hydroxide. So sodium hydroxide or potassium hydroxide, both are alkalis. What will happen? Because of this potassium hydroxide, hydrolysis will take place, and that fatty acid will be separated from glycerol. That fatty acid will also be separated. All the fatty acid will be separated from the glycerol, and then what will happen? The potassium ion will also be separated from the OH, and that potassium ion will come, it will attach with a fatty acid. Now there will be 3 potassium hydroxide, so 3 potassium that will attach here, fatty acid at the end, potassium ion, fatty acid at the end, potassium, like this. Let's suppose COOH. This is a fatty acid, so potassium ion will attach here. Now you can call it a soap as well, but for soap we use sodium hydroxide. This is now what happened now. This is called a saponification, right? So here in the saponification number, we just want to check the size of the fatty acids. Okay, because sometimes we have short chain fatty acid, and sometimes we have long chain fatty acid. Different oils, different fats have the relative size of fatty acid that is already very well known. So we will check the size of the fatty acid in that particular fats or oil. It will also tell us whether it is pure or not. Let's suppose here you will take 100 gram of fats, and then you will react it with potassium hydroxide. Let me tell you one more very special thing, that if this is one beaker and 100 gram of fat is present, and this is another beaker, 100 gram of fat is present in both these two beakers have 100 gram of fats. But here in this beaker, the fatty acids are present, but they are very short chain, right? 1, 2, 3, 4, 5, 6 fatty acids are present, but they are short chain. Here there is long chain fatty acid, right? There is long chain fatty acid. 3 fatty acids are present. Their mass is 100 gram. 6 fatty acids, their mass is also 100 gram. Masses are same, but the problem is that here we have 6 fatty acids, here we have 3 fatty acids. These 6 fatty acids also have their own COOH group. And so here we will expect that here we have 6 COO, 6 carboxyl group. In here we will expect 3 carboxyl group. And now how we will find, because we can't see these relative size, the length of the fatty acid with our eyes, we can't see. So if you want to check that in the given fatty acid either it contains long chain fatty acid or short chain fatty acid, then you will perform saponification number. In saponification number we will add potassium hydroxide. Of course, some milligram, in milligram, 10 milligram, 100 milligram, whatsoever. We will react this potassium hydroxide with the fat, and then we will come to know its value. If maybe some 10 milligram, 100 milligram, some value will come to us, and that value will be compared. That value will be compared with the standard, just like in iodine number. So here is the standard values. For human fat, we have 195 to 200 is the value, and for butter is also some sort of fats. Its value, saponification number, is 230 to 240, and for coconut oil that is 250 to 260. Now If you react potassium hydroxide with fats, what will happen? Saponification reaction will start, and after the saponification reaction, you will check the gram of potassium hydroxide used, because potassium hydroxide is a base. That in fats we have acid, but potassium hydroxide is base. So whenever you react acid with the base, what will happen? A reaction will happen that is called as neutralization reaction. Acid and base will react and their effect will be neutralized. So that is also a kind of neutralization. So a saponification number is how much milligram of potassium hydroxide is used to neutralize 100 gram of fats. So then you will get the number and you will compare the number. Let's suppose with the given fat, someone said that this is butter. For butter, the number should be between 230 and 240. If the number you obtained was not in this range, means there is problem in that butter. So test number 2 was also done. Now come to test number 3. The test number 3 is here, reichert missl RM number. Reichert missl RM number is another number. It is very specifically used to check butter, How and what is the target of this test? Here in this test, we will check the volatile oil present in different kinds of fats, because some fats also have volatile oil, like caproic acid, caprylic acid, butyric acid. Especially in the butter, these volatile oil are present, and we can't judge, we can't analyze how much volatile oil is present in the butter, because the presence of volatile oil, the amount of volatile oil is identity and the proof of the purity for the butter. So in this test RM number, we will take 5 gram of fat first, right? And we will distill it, especially butter. We will distill it, because with the distillation process, you will separate volatile oil. Volatile oil is present in fats. You need to separate the volatile oil from the fat. So let's suppose you have 5 gram of butter, and with the help of distillation is another separation process. With this process, you will get volatile oil. Once you got volatile oil, whatever amount of volatile oil you got, you will react again potassium hydroxide, but this time the potassium hydroxide will be in liquid tape, that is ml. And then its strength will be 0.1 N. N means normal solution. So you will take potassium hydroxide, 0.1 normal solution potassium hydroxide, and you will add that into that volatile oil. And then you will check how many ml, not in gram, not ml, how many ml of potassium hydroxide was consumed, because once again here some sort of a reaction will happen, and you will get the values again you will get the values. Now you will say, how we will get the values? I already told you that if you want to check whether how much iodine is absorbed, or how many ml of potassium hydroxide is used, or how many milligram of potassium is used, you need to perform that titration process. So don't worry about this titration process, because we will get that value, and once we got the value, we will compare it with the standard. For butter, the standard value is in between the range of 25 to 30. That is the value. If that number for butter, the number is below or above that, this means there is problem in the butter, because that is very specific identification for the butter. Whenever you want to check the quality of the butter, you need to know that if the butter is original or not. So you must find the RM number. With the help of RM number, you will easily get the purity of the butter, because many people do adulteration in butter. We can't see them, right? Just if you see butter with your eyes, you may not be able. That is very impossible to check with eyes, because we are not magicians. Now the last test is the acid number. There is no space for acid number, so I have to, okay, for acid number, what we do here, acid number, this is the fourth test, acid number. This is the fourth test. For acid number, what we do, we take out again what, again some fats, right, and we react them with a milligram of potassium hydroxide, right. This is now potassium hydroxide. We will react with the fat, and once again we will check, we will do neutralization reaction, neutralizing, because it's a base, is an acid. Why the acid number is used for? What is the target of this test? So this test is actually used to check either there is any free fatty acid or not, free fatty acid present or not, because some of the fats or oil, they, when they are refined well, they do not contain free fatty acid. There is no free fatty acid in the oil if it is refined well, right? But sometime what happens, sometime because some decomposition takes place, decomposition, bacterial decomposition, or some because of some chemical. So if you add some chemical or some bacteria come here and they will break up, they will decompose the oil. Once the oil is decomposed, then you will get free fatty acid. The presence of free fatty acid indicates the decomposition process, that this fat is not good for the human health, is because it contains free fatty acid. So again we will check that either the fats or oil contain fatty acid, free fatty acid or not. For this purpose we will add some potassium hydroxide in milligram. If the potassium hydroxide is absorbed, is reacted, it means that there was some free fatty acid was present. Because the potassium hydroxide is consumed, the potassium hydroxide utilized, and you will get some number. You will get some number. That number will be used to judge the fatty acid. If the number is greater, it means there are many free fatty acids molecules are present, and that oil is not suitable for health. And if that number is very less, the number is very less, because in the book of Satyanarayan I could not get the values for this. If the number is less, means there are only very few free fatty acids are present, so this fats is good for the health. Okay, dear students, I hope you got that topic. It was a little bit lengthy but so interesting. If you got, that's fine. Not, you can repeat the lecture again and again, and you will got these tests for yourself and for the exam as well. Please remember me in your prayers, and also give us a like if you understand. Also share these videos. Also subscribe, because by subscribing that channel you will be notified for any upcoming videos. Thank you. Bye bye.